All right, what's up, guys? In this video, we're going to pick up some calculus here, and we're going to talk about limits. So we're going to evaluate a quick limit here. So we're going to evaluate the limit as t goes to 0. We got the square root of t squared plus 9 minus 3, all divided by t squared. So all you do really for any limit is just plug in the value and see what happens. Now we see that substituting in 0 here is going to create a problem for us because we're going to get 0 over 0, which is an indeterminate form. And it's important to remember that an indeterminate form does not mean that the limit does not exist. It just means that you'll have to come up with some other way of finding the limit. And keep in mind also that when we substitute in 0 for t, well, we get 0 in the denominator. That's really what the problem is. We'll get 0 in the numerator as well when we plug in, but even in this case, let's say we got, I don't know, and we didn't, but let's just say we get 3 or 7 or some other number in the numerator. It doesn't really make a difference if we have 0 in the denominator. That's what's causing the problem. So a direct substitution is just not going to work. So we're going to have to come up with something else. The great thing about limits that contain square roots, we can do rationalization in some cases. In this case, that's exactly what we're going to do. We're going to rationalize the numerator. Okay. When I say rationalize the numerator, what we're going to do is we're going to multiply the numerator by the conjugate. But if we multiply the numerator by the conjugate, we got to do the same thing for the denominator. So this happens to work out quite nicely for limits that contain square roots. So let's go ahead and do that. So we got the square root of t squared plus 9 minus 3. We'll multiply it by its conjugate, which is the square root of t squared plus 9 plus 3. Now you got to do it in the denominator too. So we'll get t squared multiplied by the conjugate, which was the square root of t squared plus 9 plus 3. Now let's keep going. So we get the limit as t goes to 0. And hopefully you remember the difference of two squares from algebra. Difference of two squares. Because that's what we're going to use to simplify the numerator. So remember, for the difference of two squares, if I have a minus b multiplied by a plus b, well, then that just gives me a squared minus b squared. Hopefully you remember that from algebra. So what that means is the numerator essentially will simplify down to just t squared. And it's going to be divided by t squared multiplied by the conjugate, which was the square root of t squared plus 9 plus 3. We can see here that the t squareds cancel out. So now we have the limit as t goes to 0. And so what we have now is just a 1 in the numerator. And what we got down here is the square root of t squared plus 9 plus 3. Now we try the direct substitution again and see what happens. All right. So if we try the direct substitution, we're going to get 1, and we substitute into 0 now. So if we substitute in 0, what we'll get is 0 squared, which is 0. We know the square root of 9 is 3, so essentially we'll have 3 plus 3, which is obviously 6. So this will give us 1 over 6, which is the limit. So that's your final answer. So this is a good example just to demonstrate once again, and this is typically only an issue with the Calc 1 students, but just to demonstrate very quickly that just because you get an indeterminate form does not mean the limit does not exist. And as you can see in this case, the limit does exist. It's just that a direct substitution didn't give us our answer. And most limits are going to be like that. Direct substitution is just probably not going to work in most cases, and you're going to have to try something else. All right, but that's how you do it. So let me know if you got any questions. I'd be more than happy to answer them. So I'll see y'all next time.